mistake answer would be?
6 to 8.
Between 6 and 8, because that's literally in the middle of the graph, right?
Yeah.
But what do we mean by median?
Middle value.
Between the 50%.
So it's middle value, so it separates the bottom 50% from the top 50%. How many data points do I have?
25.
And so if I got 25, what's the bottom half going to be? How many?
12 and a half.
12, then 1, then 12. So where's that 1?
8 to 10.
8 to 10.
8 to 10, right? So I have 10 data points here, then 2 more would be my 12. And so my 13th data point would be right here. Notice also 5, 7, 12. So I've got 12 data points here, 12 above, so somewhere between 8 and 10 is my median. Does that help us recap the concept of a median a little bit? All this week we're doing that unit 1, which was really what we did as unit 2.
Was that actually on the AP exam?
Yes? Oh.
Let's go.
Yeah. Hey guys, please hear me very clearly. Like, there are plenty of multiple choice questions on the AP exam that are very doable stuff like this, right? So, there's some tougher stuff for sure, but there's also questions like this, okay? Alright, so which of the following, now this is another question though that we do need to be aware of. Which of the following is closest to the percentile rank of a resident from this street who traveled 85 miles to work this week?
I said 70.
You said 70?
Yeah.
Why 70?
So I had 28 total, so I just counted out to 85, and it gave me like 9. if I
Yeah, so
remember right.
85 would be here, right?
Yeah.
So how many data points are at, and so remember when we say percentile, it's the percent that are at or below. So, and I would actually just count this way. 1, 2, 3, 4, 5, 6, 7, 8. If 8 are above, what's below?
20.
Divide by what, 4?
It's like 5 out of 7. So it's around 70.
5 out of 7.
Notice it doesn't have to be exact.
Which is 0.7.
But, yeah. But remember, for a percentile, we would convert that to something bigger than 1, right? Multiplied by 100.
Yeah.
So 70% are below, but that would be the 70th percentile. Now, as a reminder, would I say at or in? At. It's a location, right? So it's at the 70th percentile. Questions, comments, concerns about those review questions?
What were we supposed to do for?
Nope, just the first 3.
Good.
Alright, so let's look at the analysis of the demonstrate your understanding. Here's the first 4. And guys, looking at our Freire models, it makes sense why we missed several of these things, and we need to update our knowledge because I intentionally made the language somewhat tricky to mirror what we'd see on the AP exam. Notice, if the null hypothesis is not rejected, that's fail to reject. Do we collect evidence for the null hypothesis? No, we collect evidence for the alternative hypothesis. So I don't have evidence for the null hypothesis. I just do not have enough to reject the null hypothesis. I do not have enough for the alternative hypothesis. Right? You do not collect evidence for the null hypothesis. You collect evidence for the alternative or against the null. So update that language on your demonstrate understanding. You might want one of these, Deacon. Mr. Arliss, do you remember if the demonstrate understandings are back there?
Here it is.
I can just probably good. Deacon, go grab one. All right. Number 2. Actually, what questions do I need to answer about number 1?
Like, just like pick it up.
Yeah, it said not enough evidence.
Yeah. Right, so there is not enough evidence. And again, it's not for the null hypothesis. There's not enough evidence for the alternative hypothesis.
So we don't collect for no, we just collect.
Correct. And that's a huge thing. We don't ever collect evidence for the null hypothesis. Because remember, and I saw this a lot on your FAIR models, we need to pay attention to this. A null hypothesis is always a statement of what? Equality. It's about the parameter and it's a statement of equality. And then I collect data against that and for my alternative, which is a statement of inequality, right? Greater than, less than, not equal to. So we collect evidence for the alternative, and so we just didn't have enough to reject the null hypothesis and have evidence for the alternative. Yes, Lexi?
So could the alternate hypothesis be greater than or equal to?
No.
Or it just has to be greater than?
So remember, if it's equal to, that is the null,
Okay.
right? So it cannot be greater than or equal to, because equal to would be here. So alternative is greater than, it is less than, or it is not equal to. But it is never an equals to statement. Yes.
Stupid question, but I completely forgot. What does P mean again?
Great question. Well, and so be careful, because there's a few different P's that we have talked about. So what are the P's that we have talked about? P, well, so P hat, that's my what? Sample proportion. What other P's have we talked about?
Lowercase p.
So we've done lowercase p, which is my population proportion.
Uppercase p.
Okay, what's an uppercase P? That's a probability. And remember, we have now introduced a p-value, which the p-value is a type of what? Probability. Okay, yes?
Why so many p's? Why can't we just use different
Yeah.
p's?
So-
Because they start with P's.
But yeah, but they
Probability, proportion.
Use different words.
Okay, I will say this, traditionally, before the AP exam, what I had always seen was that the population proportion was pi, using that Greek letter.
Why is it high? Yeah, maybe
Whoa,
p
whoa,
actually
whoa,
makes
hold up. Mu for mean, sigma for standard deviation, pi, because it starts with a P.
Well, yeah, but does sigma have its own like number too? Pi has its own number.
Well, that's probably why they quit using pi, but, alright,
I didn't even know pi was Greek.
yes. Alright, I want you to look at 2 through 4. Which of these do I need to clarify? Should have done it that way. 2 through 4, I gave you notes, I put my notes up on the board. Which of these do I need to clarify?
Wait. No, wait, never mind. I got it wrong. I got it completely.
Can you explain 4?
Yeah, what'd you say?
I said, I got P. I said the power of the test is something.
Yeah, that's fine with having me too.
But what did you say? What'd you say?
I said the power of the test is, and then I gave the equation, and then I said, so it comes with the probability of accepting type 1 and type 2 errors.
Well, so 1, that's how we calculate the power, right?
Mm-hmm.
But what is the power? That. The power of the test is the probability of correctly rejecting it. The way we calculate it is 1 minus the probability of a type 2 error, right? And it's related to alpha and beta, but it's not those things. What is power? It is the probability of correctly rejecting.
How do you know the probability? I put that exactly right.
That's my question. How do you know?
Of a type 2 error?
Yeah.
Yeah, there's a lot of fancy statistics that go into it. And so on the AP exam, they will give you the probability of a type 2 error. And for the power, you just have to do 1 minus the probability of that type 2 error. We saw an example of that in the multiple choice.
I put that word for word, and I got a P.
Then you did not put that word
I
for
did.
word.
I put its probability of successful rejection for no hypothesis, and I got a P.
Oh, that's because I forgot to add this for a specific
Yeah, but you
alternate
didn't
value.
write that up there.
But that's what it
You didn't
is.
say that.
So, yes, I meant to update that when I thought about it later. Guys, don't forget the power, and I talked about this multiple times yesterday in class, the power is only for a specific value. The power changes when the value changes, right?
But if you didn't talk about it, then why did
But I did talk about it in class yesterday, I just forgot to write it up here. I updated it later and I used the wrong set of solutions when I did this. Yeah. It is customary to say that the result of a hypothesis test is statistically significant when the p-value is smaller. Remember, if the p-value is less than alpha, right,
Yeah, no,
that's statistically significant. We reject the null hypothesis. If the p-value is greater than alpha, we don't have enough evidence for the alternative and we fail to reject the null hypothesis.
And they're giving us the p-value on the test, right?
So when,
Sometimes, but usually you have to use your calculator to run a hypothesis test.
so it's considered statistically.
That's the whole thing with these hypothesis tests. They plan to conclude, huh?
So it's statistically significant when it's lower?
Yes.
I thought it was when it was higher.
No.
No,
Because
remember
remember-
the tiny one?
So remember,
So it's
what do
also-
we mean by, so like, if this is my test statistic, right? My p-value is the probability of getting that extreme or more extreme by chance alone, right? So assuming this to be my true proportion, what was the probability of getting this by random chance alone? It's when that probability is low that it's very unlikely to get it by chance alone, so I reject this null hypothesis. The smaller your p-value, the less likely it is that this is true,
Yes.
because my statistic is so far away from that parameter.
So why would it be if it says it is significantly significant? It is significant when it's larger than all.
No, it's when it's smaller, that's what I'm saying.
No,
It's not when it's larger.
But how is that? So I thought you just said that when it's smaller, it's not significant though.
No, I just said when it's smaller, it is statistically significant. That's literally what it says up
So when
here.
it says hypothesis test, it's referring to also.
No, the test is the process of calculating the p-value.
Hey, look, man, same time next week, in 2 weeks, if you know something else, you write about it.
Okay, we're gonna have to address this later, and we'll do it with some practice problems. It's a good thing I'm getting until Friday. So, this is a detail that I will say, I think Ashton was the only one who remembered this, and it was in his FAIR model. I talked about it a little bit, but not heavily. We need to remember the observed significance level, that's the p-value. Alpha is the significance level, and beta is the probability of a type 2 error. So, beta is the probability of a type 2 error. Alpha, that's my significance level, or the probability of what type of error? Of type 1 error. But if you ever see the language of an observed significance level, that's p-value, because it's literally what we observed. Was he updating your knowledge over there? So, number 6, there were lots of issues. And you just pay attention to this one. First off, the critical value 1.96 was for what confidence level?
95.
95%. This was a 99%. So, you would have to get that critical value there. What do we use this standard error formula for?
That's when we assume that the two proportions are the same.
And when do we assume the two are the same for a hypothesis test, right?
Okay.
We would only use this formula when it's a hypothesis test, and there's an issue here, which I didn't actually mean to make this issue, but someone caught it. We're always supposed to add.
I thought that was the only issue with the.
You see those other two now, though?
Yeah.
Yeah, that was the only one I didn't mean to make. I meant to make the other two. Okay.
Why do you only add?
Say again?
Why do you only add?
Well, because remember, spread and variability only increases, right?
Yeah, alright.
So you have to add. Do not forget, what's the standard error formula for confidence intervals? And also, can you find it somewhere?
Yeah, it's on the.
It's on the formula sheet.
It's p hat 1 minus p.
Oh, yeah, and you do the same thing for the second one?
Yeah.
Yeah.
Do not forget to use your formula sheet. And do not forget, why do we use p hat here with confidence intervals?
You don't have a hypothesized.
We don't have a hypothesized p-value, right? So we just use the sample proportion. Here, right, we would have some kind of hypothesized value. It's a little funky for two proportions, but there's that. And then with 7, this is one we need to pay attention to. I was very intentional about this one. When we do a hypothesis test, we at least have a hypothetical value for P, right?
Yes.
So what do we use for large counts in a hypothesis test? P, right? So that should have been n times P is greater than or equal to 10. N times 1 minus P is greater than or equal to 10. So that's for the large counts there. When do we use this one?
For the,
Confidence zones.
yeah.
Remember, we have no P, we only have P hat. So we use P hat when there is no P. And then the whole point of this is to check for normality. Remember, that goes with your z-score, your critical value. What's necessary for the standard deviation?
10%.
Say it louder.
10%.
10%. So if we think about the critical or the confidence interval, what type of data do we have to get a decent p-hat
Random.
random? A z-score critical value is built out of what kind of curve?
Normal.
Specifically a normal, is it a
Sampling distribution.
sampling distribution, right? The whole thing is built out of this sampling distribution, so normal sampling distribution. And what's necessary for this piece?
Independent.
Independence of sampling or just that 10% condition will always satisfy, right? So remember, every part of that confidence interval corresponds to something, some condition. Same thing with my hypothesis test. To use Z, we have to have what?
Normality.
A normal sampling distribution, right?
Yeah.
To have a decent p-hat, I have to have
Random.
randomization. To use this formula, actually, there's something wrong with this formula. What is it?
You're using p-hats.
Right. If I'm doing a hypothesis test, don't I have a hypothesized p?
Yeah.
So I would use p there. But then again, 10%. So those conditions tie directly into this formula. And one small recap detail, can you ever say a distribution is normal?
No.
It has to be approximately normal. You cannot say a distribution is normal. It has to be approximately normal, or at least your language, because it will never be perfectly normal. Yeah.
Okay, never mind. You just answered it though last.
Okay.
I was about to ask, like, would it ever be normal? Like, would there be
Um,
one that's normal?
Sampling distributions and distributions can be theoretically normal, but in the real world, they're never normal.
Okay.
Just like there's not a true perfect circle in the world.
I still think that's a lie.
Okay.
Like, I bet there's
Yeah,
only one
mathematically
perfect
it's
circle.
Okay, you can think that.
Right?
Um,
What's the science behind there not being one?
Huh?
What's the science behind there not being one?
Well, like, can't you, like, with, like, math?
We've collected enough evidence to reject the belief that there is a perfect circle.
There's a
Maybe
band called
false?
Perfect Circle.
Cool.
There is.
There's got to be.
Alright,
It's just a
I know, we're starting a circle.
I've already, I got this right.
but remember, a circle is the collection of all data points that are equidistant from the radius. There's always some slight imperfection, so that not every point is exactly the same distance.
Computer command or something.
Not in the real world, though. That's what I said.
Oh,
Okay.
okay, that makes sense.
Alright, so looking here, please do not forget, because this is one of the things, you can use the calculator actually here, guys. You could use it. You could use a calculator here with each of these to actually calculate the p-values for each test. But, like here, I know some of us got distracted by a higher sample size. But if my hypothetical,
Wow.
thanks.
Nice.
Alright. If my hypothetical is that p is 0.35 and my statistic is 0.35, what's the probability of getting not equal to 0.35?
0.65.
And if your hypothetical one is your alternate, it
Remember, I was,
100.
right, because my p-value, remember, it'd be like greater than, but then for not equal to, I would double it for the two-tail, and so my p-value would be huge. My p-value would equal 1. In order to have a p-value, we always want to look at values further from the statistic. So we're automatically down to b through e. And so what's going to help us have a larger p-value when we talk about sample size?
Bigger.
Larger sample size.
So Bryson, what happens to our sampling distribution when that sample size increases?
Spread decreases.
Spread decreases, right? And if that spread decreases, but my statistic stays the same, there's less area outside, right? So, for example, let's say that this is n equals 60. Well then, for n equals 100, it would look something like this. It's exaggerated, but let's say that's n equals 100. Notice that's less spread out, right? The center is still 0.35. But now that 0.4, that 0.25, let's say 0.4 is here. Which one has less area to the right? The 100, right? But what's going to have even less area? A bigger distance from the hypothesized value. Notice this difference is 0.05. This distance is 0.1. So that would be even smaller p-value. So when do we get smaller p-values? And this is a note I would make to myself because this shows up. Smaller p-values are when our statistic is further from the parameter and when we have a higher sample size. Right? The higher sample size reduces that spread, reduces that variability, and the further that statistic is away, it's easier to reject the null hypothesis. And that's a great way to think about that.
Larger size or smaller size?
Larger size, because remember, the larger the size, the less spread in the sampling distribution.
So so stat is farther from parameter, how does that affect the p-value?
So notice, like, if this is 0.4,
Yeah.
you see how much area is to the right of it? So that would be the
I know what
p-value.
you're saying.
But if it's 0.25, it'd be way over here and there's even less area. And just think about it this way, and I'll get to your question, Tyler. Think about it this way. When's it going to be easier to reject my null hypothesis? When my statistic is closer to it or when it's further away? When it's further away because it has a smaller
I
p-value.
got you.
Tyler?
Isn't this a discrete variable, so would the p-value for option A be like not done?
But we're building on a sampling distribution, which becomes a continuous random variable. That's a good question and good thoughts, legitimately. But yeah, once you make it a sampling distribution, it becomes a continuous random variable. It would be a binomial though, right? Idea? So discrete in that way? Yes,
Bryce.
Bryce?
Say we would pick 0.25 over 0.40.
So remember, what was my hypothesized value?
0.35.
Which one's further away?
0.25.
0.25. And so remember, we're trying to find evidence to reject that null hypothesis.
Mhm.
When's it going to be easier to reject? When my statistic is further away. And that's because I would have a smaller p-value. So notice, and Bryson, that's why I drew this out. This is all hypothetical, but you can see with this 0.25 being further away, way smaller p-value.
Yes, sir.
Wait, so we're trying to reject the null.
You always are trying to collect evidence for the alternative.
But
Which, if you have enough evidence for the alternative, you reject the null hypothesis.
if p-value is larger than alpha, then you fail to reject the null.
Correct.
So then why would you want the p-value to be?
You don't. That's why we just said, through all this, what do we want? A small p-value,
I got you.
right?
Good.
I want to reject that null, so I want a small p-value. Yeah, a lot of us missed this one. It's because of something I already addressed. when we do a hypothesis test, right? Okay, how do we do, first off, I do want to remind you of this, and please write this down, because this is on the formula sheet, and this is going to help you build this each time. What is the general formula for a standardized test statistic?
Sorry.
Or stat?
So it's a statistic, or, that's my point estimate, we'll just call it stat for now. So stat
Minus the parameter
minus a parameter
over standard deviation.
divided by standard deviation or standard error. Build all of this based on your hypothesis. So Austin, what type of hypothesis would I be looking at here? Or what type of test would I be looking at here?
Oh, I was just doing the Z. I don't know.
But the Z is to help us calculate a p-value. It is a type of test. Is it a 1 proportion Z test, a 2 proportion Z test?
Maybe a 2 because you're adding.
Okay, so notice it's a 2 proportion Z test, right? And I wouldn't be adding, I would be subtracting, because I want to know whether it's different from, right? Now, that means, and I wouldn't necessarily write this out here, but that means that what would P1 minus P2 be?
0.
It equals 0, the difference. That's my null hypothesis. So what's my alternative hypothesis? Not, right? It just says different. Now the reason I bring this up is use your hypotheses to drive the formula that you write out. What is the statistic for this parameter?
P hat 1 minus P hat 2.
Right? Doesn't that estimate P1 minus P2?
Yeah.
Okay. What would the parameter then be?
Parameter would be P1 minus P2 as listed
And-
in your hypothesis.
Technically, that's because what is the mean of P1 P1 hat minus P2 hat?
P1 minus P2 hat?
Remember, that's
Yeah.
that's from my sampling distributions. Everything with hypothesis tests is built out of sampling distributions. So it's the mean of P1 hat minus P2 hat. We found out 3 chapters ago it's just P1 minus P2 divided by
Square root.
and I will point this out, technically we should be thinking, right, standard deviation of P1 hat minus P2 hat, the typical distance that statistic differs from the mean, which would be this. But what is the problem with this formula? Because that's what we would see on the formula sheet.
We don't have a P.
We don't have a P, right? So we don't have that P there. So what do we need to calculate instead of using P1 and P2? So remember, this is where we use the combined sample proportion. That's where we use that combined sample proportion. And so this one took a little bit more work, but notice right away, it's no longer the 0.17, 0.83, and 0.25 and 0.75. You can eliminate A, B. Does anyone see another one that we can quickly eliminate? E, right? We don't want 0.5s in there. Okay, so we are down to C and D. I'm going to tell you, I didn't do the calculations, but I knew this. 0.21 is right in the middle of 25 and what was the other one, 17?
Yeah.
But didn't we have way more than 25? 600 adults? So I should be closer to 25% than I am to 17%, not directly in the middle. That's logically how I did it. Now you can also calculate it because it's the number of successes divided by the total sample size. And this is a pain in the butt, but you can do it because you know how to find the number of successes. 0.25 times 600 divided by that 200 plus 600. And that is a pain in the butt. So if you can do it logically without having to work it all out, you end up with this. That combined proportion. Yes?
I'm so sorry, but I did not hear why it wasn't B.
Because, so there's actually two reasons. First off, we don't have P1, right? And that is P1 hat. We only use P1 hat when we're dealing with confidence intervals, because we don't have a population proportion, right? Does anyone see the second issue with B?
The second issue would be.
Yeah, the sample sizes are swapped. Didn't the 200 go with the first sample? The 600 went with the second sample? So there's two issues with that B. But again, when you're dealing with hypothesis test, you have got to have that combined sample proportion. And I think they even have that on the formula sheet, right? Yeah. So notice when it says when P1 equals P2 is assumed, and when do we assume that? With hypothesis testing, okay? So use your formula sheets to your advantage. And so we had to use the combined sample proportion here. Now, I will remind you of this. Does anyone know a quick way you could have found that combined sample proportion without having to do all that work?
Oh, yeah.
No?
Yeah. Alright, so it's 17% of 200, so that's a flat number. So 17 times 2 is 34.
Yeah?
You add that to like 600 divided by 4, that's 150. 150 and 34 is 184.
I agree, but I'm saying without having to do this work.
Oh. I mean, that's like without like, I didn't punch that into the calculator.
I know. But is everyone else going to be able to do that? Here's what I would point out. Could you have run the hypothesis test?
Oh, yeah.
And the hypothesis test on the calculator spits out the combined sample proportion. We're going to see that later, but that's important to recognize is that the hypothesis test on the calculator would have spit out that combined sample proportion.
So would this be the 2 sample proportion or?
So this is a 2 proportion z-test. Yeah. What's up?
Can you do the hypothesis test, because I asked Haley and she didn't know. But
The hypothesis test on the calculator?
yeah.
All right, everybody pick up a calculator. Ding.
Yeah, I know, I'm not.
I'm glad you know it.
All right, so what do I need to press because it does cool crap? Menu. Okay? So I'm going to go to menu. Under menu, I'm going to hit what? Stat. For statistics, then stat test. Now, look at your statistical test. What type of statistical test are we trying to do?
2 proportions.
And remember, we're dealing with proportion, so a 2 proportion z-test. So number 6, and you have to find your successes. Now, here's what I'll pause and point out. This is why the scratch pad, listen, guys, eyes and ears here. This is why the scratch pad's good. I know that Ashton was like, oh, I know 17% of 200, but some of us don't know that. But if I click this little scratch pad above tab, it's just going to put, it should have, just kidding. It doesn't help when I'm in this space. Oh, that was not what I wanted.
Is it in 34 though? Because you just multiply by this.
Yeah. Here's another option.
Just write it down.
You may have to, yeah, you may just have to do it before you start the test, because you know that it's going to ask for the successes. So 34 was our sample size. 200 successes for sample 2.
150.
150. 25% of 600. Yep. Sample size is 600. Now, we don't have to stress about it here, but in the problem it does say different from. So what would the alternative hypothesis be? Not equal to. And just hit OK. Notice that running that test gives me a whole lot of information. Does anybody see where my combined sample proportion is up here? See that p hat? That's 0.23. So running your hypothesis test will give you that information. We just have to know how to put the stuff in. So that calculator. Okay. So again, look for those incorrect details. So this is actually another good example to look at. So what is the question asking here? Is there what?
A difference between the two?
There's something else.
Convincing evidence.
Yeah, convincing statistical evidence. What do you have to do when the AP exam asks for convincing statistical evidence?
Draw an hypothesis.
You gotta run the hypothesis test.
Yeah.
Now on the free response, you gotta do state, plan, do, conclude. But on the multiple choice, what can you do?
Use your calculator.
Just plug it in that calculator, right? So random sample. Okay, so we actually have another two proportions one. Woo! So let's look at our first proportion. So stat test, 2 prop z test. So looking here, what was our first number of successes? 94, right? Of those with school-age children, 94 opposed the banning for a sample size of 230. For those without school-age children, how many opposed the banning?
147.
So 147 out of, was it 341?
Yeah, 341.
And so what was the alternative? So here it asks for a convincing statistical evidence of a difference.
So it's not equal.
So not equal to.
We ever do one that we're supposed to be less than or greater?
Yes, we'll see some examples of that. I want you to notice, and so like the whole thing is that p-value is measuring the probability of getting that extreme a statistic or more extreme by random chance alone. On the free response, you're going to want to draw a normal curve. Where would I mark on my normal curve? The what?
Right here.
I mean, ish, but
That's what you want.
that's not really what I want
You
to...
want to do the two tails.
I do want two tails, but based on this hypothesis test, where am I going to mark on this curve?
Like halfway between, like at 0.5 on both sides, at 0.5 and negative 0.5.
So negative 0.35 or 0.31, and then I would shade which direction?
To the left.
To the left. Now, because it's a not equal to, it is two tails, so it's not just this. It would be this and this. So that total area is 0.595, right? And so that's what we want to recognize here. Like this would only have been half of the 0.595. The calculator already gave us the double, okay? So
So you have to take that p-value and divide it by 2 and put it like on
No.
the side.
well, no. I would have I'm just showing that this section would have been half of this. It's already doubled it for me. I just want that p-value.
Well, I'm just saying, like, if you're drawing it, that's what you're.
But I'm not concerned about the p-value. I just mark the z equal to negative 0.531.
Okay.
And this z equal to positive 0.531, right? It's two-tailed.
Gotcha.
So notice p-value, that's the probability of getting this extreme or more extreme by random chance alone. How likely was it to get that?
Pretty much.
That was pretty darn likely, right? Almost 6% of the time by random chance alone. So do I have enough evidence for my alternative? Nope. The probability of observing a difference at least as large as the sample difference if the two population proportions are the same. Notice this is my null hypothesis because the whole point of a p-value is assuming the null hypothesis is true, right? So p-value is probability by random chance alone if null hypothesis is true. With those calculations, we always assume the null hypothesis is true. Okay? Are there any of these that we picked that we're confused on language-wise why that is incorrect.
I got everything right besides yes and no, like.
But remember, if my p-value is less than alpha, right, that's statistically significant. If p-value is greater than alpha, it is not statistically significant. So it is a very low chance. It is greater than that 0.05. So here, one of the key conditions, well, first off, let me ask this. Which of these distracted us? Because more of us did miss this than I thought we would. What happened? Number 11.
I was confused. I didn't think any of the answers were right, so I tried to pick one.
Okay, but here's the thing, like A, there's got to be at least one. Here's the thing, guys. Is it ever enough to say, hey, this value is clearly larger than this value and not run a hypothesis test?
No.
You can never just not run a hypothesis test. If we need convincing statistical evidence, you got to run the hypothesis test. Every time. The results of the test were invalid because less than 10% of the population was sampled. Actually, don't we need less than 10%?
Yes.
That's one of my conditions. Dan performed a two-tailed test and should have performed a one-tailed. Well, what did Dan want to know? Well, there was a difference. So it was a difference in two proportions, two-tailed versus one-tailed? A difference in proportions has nothing to do with the tails.
So what is
A difference in proportions is this. Right? Looking at the difference in proportions. Right? That difference in proportions is not one-tailed versus two-tailed. Difference in proportions is literally a difference in the two proportions. But he did a two-prop z-test. Did he actually have two independent samples? No. It was how many samples? One. This percent came from the same sample. Those are not two independent random samples. When you do two sample stuff, those samples need to be random, but they also need to be independent, right? One sample cannot affect the other. Okay? So do we understand difference in proportions? It's got to be two independent samples. We didn't have that. And if you don't have two independent samples, you need to do a one sample test. Alright, I need us to pay attention to how to interpret a p-value. At least the Frere models that I saw, we wrote down the definition of a p-value correctly, but we're not applying it correctly. We talked about it a few times, right? What is p-value?
Getting that value more extreme.
So probability of getting that extreme a statistic or more extreme by random chance alone if the null hypothesis is true. So it is true that 60% of the trees are classified as softwood. Oh no, if it is true that 60% of the trees are classified as softwood, 0.015 is the probability of obtaining a what? Population proportion. Are we ever obtaining a population proportion?
No.
It's always a sample proportion. We gotta be careful about that language, right? We collect statistics. We do not collect parameters. We use our statistics to make inferences about the parameters. So notice how this is my null hypothesis each time. So if it is true that 60% of the trees in a forested region are classified as softwood, 0.015 is the probability of obtaining a sample proportion as small as or smaller than the one obtained by the botanist. That's very close, but what's the issue?
The wrong way.
It's the wrong direction. If it's smaller, what would the alternative be?
Alternative would be that he's smaller than 0.2.
Yeah. This time, my alternative would have been that p is less than 0.6. Right? Smaller. Less than 0.6. But it asked, or the alternative here was greater than. D and E are out because what do we have to assume? Null is true, right? We have to assume the null is true. That's why D and E are out. If you need to write down any notes about that, because that p-value interpretation is important. You need to write that
That's the only
note.
part I got wrong, but that
So
was
you-
false.
Say again.
I think the only thing I got was that it was not.
Yeah. But remember, like, to do a p-value, the whole thing is the assumption is that the null is true. Guys, the whole thing with the p-value is assuming that the null is true. And so all I did was I took that wording and I put it into context here. Yes?
Nothing, could I just put a different thing?
I think the most common mistake was people put D on this one.
Yes.
But remember, a confidence interval is always to estimate the what? Population. Confidence intervals are always to estimate the population. Do I need to estimate the sample proportion or the difference in the sample proportions?
No.
I have a difference in the sample proportions. So guys, and this is one of the things on the Frere models I saw that some of us need to update for sure, is that we have to make sure all inference procedures are taking a statistic and making a conclusion about the parameter. The whole point of inference procedures is we take a statistic, make a prediction about the parameter. And so it's a proportion of all voters. That's what the interval is trying to capture. So for 14, these are the conditions for a hypothesis test. I will point out there's a slight change in the conditions if we're doing a confidence interval. So I don't particularly love this question, but there is no option for just 1 and 2. But it had to be 1 and 2 for sure. What would be the difference if we're doing a confidence interval? It'd be p hat if it was a confidence interval. But guys, those are the 3 conditions. Random, sample, or random assignment. N is less than 10% of the population size. And large counts for normality. So Deacon, you were asking earlier about how do you calculate beta? You don't, but a question like 16 could come up where they give you the probability of a type 2 error is 0.18. And then the power is just 1 minus that probability of a type 2 error. That's how, that's literally what the AP exam could do, right? Nice and easy, right?
I thought, when you taught it, and it was on the quiz, I thought I was doing it wrong. I got it too easy.
No, it's an easy question, and it shows up on the AP exam sometimes. A question just like that. Do we need to talk about 15?
So the power is just 1 minus the probability of type 2 error.
Right, so remember if you, so remember guys, what's the consequence of lowering alpha?
Increases beta.
It increases beta, and if we increase the probability of a type 2 error, it decreases my power, right? Because if this was 0.07, and because I lowered alpha, that beta went up to a 0.12, then the power here would be 0.93. The power here would be 0.88. And so my power went down,
Got you.
right? So that power goes down when you decrease your alpha as well. So there's consequences of lowering your alpha.
I get it. So they're kind of all like alpha, beta, and power all kind of interlinked.
Very related, right?
But wait, what's the connection between alpha and beta?
Well, it's not a direct calculation, but if alpha goes down, beta, so alpha, the probability of a type 1 error, if that probability goes down, I sacrifice the probability of a type 2 error, and so the beta would go up.
Right.
And if alpha is increased, so I am more likely to make a type 1 error,
So
my
they're
probability of
inversely
type
related,
2 error goes down.
So they're inversely related.
They're inversely related, yeah. Okay. Hey guys, this one killed me. Hypotheses. Statements of equality. Austin, hypotheses or null hypothesis is a statement of equality, right? Bryson, null hypothesis is a statement of equality. Peyton, null hypothesis.
It's a statement of equality.
There we go. Alternative is always a statement of inequality. So, Lexi, can I say less than or equal to? No. Guys, do notice it literally told us, right? Normal rain is slightly acidic. Normal rain has a pH of 5.5. So if it's acid rain, it'd be less than 5.5. Right? Right? So,
What, pH?
yeah, I would say, notice we haven't done much with mu, right? But at the same time, it literally says what? Let mu denote the true average. I'm not doing statistical tests with this, but we need to recognize it says let mu be the true average for pH in this area. Okay? So, type 1 error, reject your null when the null, yes. Haley?
So we don't have to include any context for the hypothesis?
If I was running a hypothesis test, yes. Probably should have or could have here, but that was all I was looking for. Okay. Maybe I should include that for the future. But notice type 1, rejecting the null hypothesis that the true mean is 5.5 for the alternative. But what is the, so we reject the null when the null is, well, no, for type 1, we reject the null when the null is true. And so we just had to put that in context. The AP exam may ask you for a consequence of that, right? So be aware of that. Type 2, failing to reject, right?
Yeah.
When
That's not true. Or
when the
alternative.
null is false or the alternative is true. So that the true, so failing to reject that the true mean pH is 5.5 when the true mean is actually less than, right? So think about your errors. I think a couple of us actually drew a little box out to help us remember where the errors go. I think that's a very effective strategy for the AP exam to help on something like this. Just take a little extra time. Remember, you got 2¼ minutes per multiple choice. Yep. Alright. And I can print this out if you need more time to write it down, but we gotta get moving. So, hey guys, remember for this one, yes sir,
You said type 1 is when we reject the null and the null is true, and type 2 is.
when you fail to reject the null, but the alternative is true. Okay? Guys, for part A here, you didn't have to do the state plan, do, conclude, you just had to put it into the calculator, right? Do not forget, is this a 1 prop z interval or a 2 prop z interval? We got 2 independent random samples, right? So the 2 prop z interval we did earlier, right? You don't subtract those two, because I think you tried to do 2 different intervals, and then you added them, okay? But it's a 2 prop z interval for the difference in those proportions.
I realized that afterwards.
And how do we find this in the calculator?
How do you find what?
Never mind, that's just a good question.
What was your question?
You used to, yeah, you used to do properties.
Yeah, it's just 2 different samples, so a 2 proportion z interval.
Okay, yeah.
Okay. Yes, sir.
Wasn't that 2 points on the?
Say again.
Just 2 points.
Yeah.
Maybe yesterday?
What was
Percy
it?
and Tyler.
Was it the,
It was just getting it. Because the multiple choice were each worth 2 points, so I felt like that was the same value as the multiple choice. That's why I did it that way. All right, please notice here with B, this is what you need to pay attention to. If there was no difference between males and females, what would I expect to see as a difference in P1 and P2? I would expect to see a 0 in there, right? So, is there a 0 that was captured?
No.
So, do I believe that there is no difference? No, I have convincing evidence, right? Notice how I went into the confidence, interpretation of that confidence, right? Could have done a hypothesis test, but we already had this interval. With 95% confidence, the true difference in proportions of men and women who would respond. I need y'all to pay attention to this language. So many of us said who responded or who responds, right? Talking about the sample. I had to use this to talk about the population, right? So you have to include that word would. So the proportions of men and women who would respond less than 1 week is captured by this interval. It's got to be about the population. So if you see a 3 out of 4, that's probably what you missed, was that detail about it would be who would respond this way. Right, so it has to be about the population. So 0 is not even a possible value. There is convincing evidence there is a difference. What's your question, Bryson?
I don't have a question.
Okay. Austin, did you make that note to yourself to pay attention to the, no, not in your brain, on that sheet of paper so you can use it to study?
I did it twice. I got the same thing.
Okay. Make sure. All right.
Just make it
I want to look at a couple of quick things from the notes. So get your note sheets out. Just want to check to make sure I address a couple of things correctly. So,
No, well, wait for Sack. Let me Sack can bring him Friday. Wait for Sack, I can bring him Friday. Langford. Yeah, he might have extended it.
all right. I think this is probably page 8, 7, I think, for this set of
I
notes.
spent like 15 minutes and went to buying 30 cans, like bring me in.
Page 7, is that right?
What time?
Be there. Oh, 7's on the back side. That's
Ran into my mom.
Okay.
He probably ran into my mom. Because he said he was racing.
Your what? No, I need to get those.
My mom said she
I'm
wants to
gonna
slow
do
down.
feedback on them. I still have those. All right, hey guys, right here. I need us back on task. I need to talk about this one. So, we haven't done this hypothesis test yet, have we? Okay, so we're going to do some other practice in a second. I just want to remind you, if they ask, which I think it later says, so it says state the hypotheses, what would that A portion be on page 7? Like if you're thinking about your hypothesis test, what would A be there?
So you have a null and
Sorry, let me rephrase this. Not asking what the null is and all that stuff. Think about your process for doing a hypothesis test.
yeah.
So A is my state. You need to pay attention to that. A is the state. What is B? It says show that the what? Conditions for the inference are met. That is my plan. Remember to include the name of the inference procedure. Say again. So then the C is my do. A lot of us did not have these notes in our FAIR models, and we need to make sure this is included. What is required for the do section of this? We need our formula.
Normal curve.
We need a normal curve. But after or with all that, We use the calculator. So,
Wait, so when you do the hypothesis on the calculator, it does all the stuff in like the formula for you, is that what it is?
so yes, but it doesn't show the formula substitute into. The AP exam wants you to substitute those values into the
I
formula.
was asking. like,
Yeah. So like it does all the calculations for you. You have to draw the normal curve based on the z-score. You need to draw or use the formula, things like that. But the calculator does the majority of the work. And then D, what's that D section? What are the 4 things you have to include in your conclusion?
You have to say that you reject or fail to reject.
So you need a statement about the null hypothesis based on what?
This like
Which that comes from the p-value versus alpha, right? Null hypothesis based on p-value versus alpha. There's 2 things. Then we need a statement about the alternative hypothesis in, you need all 4 things. You need the null hypothesis based on the p-value versus alpha and the alternative hypothesis in context. Every inference procedure, what are the 4 steps? State, plan, do, conclude. State, plan, do, conclude.
Speaking of said state. Which is this one?
Okay. We're not going to go through all the work for this because we don't have time. But I need everyone to look at this setup, and I want you to tell me what type of inference you would be making. Not what the inference is, but what type of inference you would be making based on this information. You think it'd be about a population?
It's a cause and effect.
So we're going to do something with P1 minus P2, but Ashton, what did you say?
Like you're inferring the existence or the non-existence of a cause and effect relationship.
Awesome. Why do you think Ashton's talking about cause and effect here?
Isn't
Ah, is this an experiment? What is key language here that tells us this is an experiment?
The word experiment.
So first off, do they use the word experiment?
Yeah.
But I also want to point out they use what term? Did they randomly select or randomly assign? They randomly assigned to what? Starts with the T. Treatments, guys. There was random assignment of treatments and it's an experiment. We're talking about cause and effect. Most of us did not talk about the experiments on our FAIR models, but the whole point of an experiment is to establish cause and effect, which is why with experiments you always need a 2-sample confidence interval or a 2-sample hypothesis test. So pay attention to that language. Notice that we have an experiment. So my inference is not about a population. It is about what? The drug. So cause and effect. So which one is more effective? Make that note, please. When it is an experiment, we need to know how to see an experiment. It is all about that cause and effect. By the way, Joseph, did you mean to leave your Honor Society sheet yesterday?
Yeah, I gave it to Tyler.
You what?
I gave it to Tyler.
To Tyler? So you don't feel like just doing? Okay.
I don't want it.
Okay. Just wanted to make sure that you didn't need it. Alrighty. Final couple of details here. Okay. Is it okay to use your calculator for the do step?
Yes.
Yes. But show the formula, the normal curve, and calculator values, because can you mess up putting stuff into that calculator?
Yes.
Yes, but if you show all of this, they will definitely give you at least a P, maybe even an E if they know that you just made a mistake putting it into the calculator. Okay? So that's something to pay attention to. Now, last detail before we do some AP free response questions. to prepare for that test, I want you to read through this context here, okay? It is, I think, it's on page 8, okay? So I want you to look at page 8, or up here. I just want you to think about the answer to A.
No.
Hold on, let other people think. Make sure you have convincing evidence for why you think whatever you do. Give me a quick thumbs up when you think you have an idea.
Idea just for the answer.
All right, Logan, what do you think?
No,
Why not?
because Apple isn't, not everyone has an Apple or iPod, so that's a reason. Even though some people could have gained it from that.
Okay. Does anybody want to add on to or push back on that information?
There was no experiment about the the iPod wasn't in either of these experiments. They can't compare teenagers with an iPod to teenagers without an iPod.
Notice this statement would be about what? Cause and effect. So while you are correct, what is Logan referring to? Not really the cause and effect that we want to think about, but he's referring to the
Correlation.
It is correlation. No, say it again. Confounding, right? There's confounding involved in this, which is why we cannot make a statement about cause and effect, but we can make a statement about what, Tyler? Correlation, right? So remember and keep those separate, right? Can we blame them? No, because it was not an experiment. I can't establish cause and effect. Why? Because it was confounding, like what you indicated. So we need to keep in mind cause and effect, and the confounding can cause problems. Notice some of this is helping us review a lot of that experiment stuff from beginning of the course. Time for us to get a watch. Oh my gosh, we got 15 minutes left.
Thank God.
Yes. All right.
Oh, what a bummer.
Sir. Go
No.
run like the wind, bullseye. Okay.
So tell people no.
Yeah, Logan's gonna say no never again.
It's not as important to you to be in here. It's your choice. All right, number 3. I know. All right. So this is the free response question I asked you to do last night, which Joseph actually also left behind, and Deacon didn't get. But here you go,
And I didn't do.
and somebody didn't do. But let's look at it together.
I did the board. I totally forgot about this.
How many are there?
So it's only number 3 on the 2010, and then the 2021 and 2022 ones.
I most
You
definitely-
do or don't have this?
I do.
Okay.
Why do these all say question 4?
Well, because I will point out, anyone want to take a shot in the dark? What question is most commonly the confidence interval question or the hypothesis test question? Probably number 4. Yep, there we go. 4 and 5 are regularly the inference procedure questions. So number 3, give me an interpretation of the 95% confidence level in the context of this study.
We are 95% confident that any interval created in like the same method will capture the true proportion of households that own at least one dog in the county.
Okay, so let me see if I remember this correctly. So you're saying we are 95% confident that any interval will, what?
Any interval that we conduct, that we make the same way,
Yeah.
will capture the true proportion of households in the county that own at least one dog.
Okay. Anybody want to push back or add on to that language at all?
I think it's like 95% of the time in many repeated samples.
And so here's what we need to keep in mind, these two differences. That's interpreting the confidence interval. We are 95% confident. But the confidence level is how confident we are in repeated sampling. So in the long run, remember we talked about that confidence level, right? So in repeated sampling with the same procedure or same process and sample size approximately what percent? Cold?
Yes.
Approximately what percent?
95.
95, right? So remember, that's my capture rate. So approximately 95% of the intervals will what? Capture what?
That's your proportion.
I feel like you're missing something. Anybody know what he's missing?
Of household, context.
Context, true proportion of households in the county that own at least one dog. In repeated sampling with the same process and sample size, approximately 95% of the intervals will capture the true proportion, but we need that context. Yes?
May I have one?
What happened to yours?
I don't know.
Okay.
I don't think I
Grabbed it?
got it, yeah.
Gotcha. Okay. Notice sometimes with confidence intervals, are they going to make you do the whole procedure?
No.
No, this one didn't, right? That's actually one of the reasons why it's a number 3 and not a 4 or a 5.
So, do both confidence levels and confidence intervals use repetition? Or?
No, so remember with a confidence interval, we are 95% confident that the interval captures the parameter. Why? Because in repeated sampling with the same process and sample size, approximately 95% of the intervals will capture. Right? So the confidence interval, the interpretation of the confidence interval is we are 95% confident in capturing the true parameter, or the parameter. Why? Because the confidence level is interpreted this way. So a confidence interval is one interval, but we are confident in it because in the long run, 95% of those intervals will capture. Right. Okay. So Humane Society selected a random sample of households in its county and used the sample to estimate the proportion of all households that own at least one dog. The conditions for calculating a 95% confidence interval for the proportion of households in this county that own at least one dog were checked and verified, and the resulting confidence interval was 0.417 plus or minus 0.119. Bless you. National Pet Products Association claimed that 39% of all American households have owned at least one dog. Does the Humane Society interval estimate provide evidence that the proportion of dog owners in this county is different from the claimed national proportion? Why not? So, notice, what would this interval be? How would I find out what the exact interval is? I would say 0.417 minus 0.119, what is that lower bound?
0.298.
Point what?
298.
And then 0.417 plus 0.119 gives me
0.536.
So, that 39% is captured by this parameter. So, is it plausible that the National Pet Products Association claim is true?
Yes.
That's what we want to recognize, right? That is a plausible value. So does that mean I believe that value to be correct?
No.
No, that value is just plausible. If it's a plausible value, then, and so I will say this, does it provide evidence that the proportion of dog owners is different? No. Do we have evidence? The evidence that it is different? No. Because 0.39 is a plausible value. Any guesses how to figure out how many households were selected in the Humane Society sample? This isn't a common question, but it is something that has shown up throughout the years a few times.
You use a formula sheet and you're working backwards, so.
Like your margin.
Yeah, so I have to use my what?
Margin
Margin of error, right? So what is my margin of error?
It's the statistic plus or minus the critical value times the standard error.
Yep,
So-
and so I'm just gonna point out, like, in this problem, my margin of error is 0.119, right? And so that margin of error is equal to my critical value times my standard error. And so Ashton even said, pull out that formula sheet. And so looking at this, do we know what the critical value is?
Should be 1.96.
Why 1.96?
Just the critical value, 95%.
It's just a memorization.
Right? But because it's 95%, right?
Yeah.
Remember I've told you, 95, 99, and 90%, those are the three most common ones. It'd be a good idea to know those critical values, but you can also use the calculator to help you find it. Does anyone know any more about the values here? Are we gonna have to make some assumptions?
1.5 or p hat.
So if we were trying to find the minimum sample size, you are correct. But I know what p hat is.
It's 0.4.
0.417.
Remember, that's my p hat in this case. And now solve. Right? So you are 100% correct if you were saying, hey, we want to limit my margin of error, but if I have a confidence interval, I have p hat, I solve for n. By the way, these calculators can solve equations for you. You don't have to actually do it by hand.
I like
Have I shown you how to solve it in the calculator?
Do not.
Yeah.
Probably working it out right now.
So, watch this. What's the button that lets me do cool crap?
Hey.
Menu, okay? I'm dealing with an equation which is known as algebra. What's that first option there? Numerical solve. And so I can type that equation in, 0.119 equals 1.96 times the square root of, what is it, 0.417 times 0.583 divided by, I'm going to use x just because that's standard.
How do you do an equal sign?
Oh, no.
Equal sign is top, left, underneath control. Just once you type in your equation, you have to hit comma and then x. There's my sample size. Now you can solve it like normal, and they probably want to see that work, but that calculator can solve it for you. So my sample size was probably what? 66. So you have to make sure that the comma x is underneath. So your comma x is underneath the square root, meaning outside.
Enrichment today.
Tomorrow. We can do the quizzing today if you want to.
Okay.
We just get a few done.
All right. Now,
Now,
not stressing, huh?
I got
Oh, we already
people on
talked
the
about
list,
it.
they're already
What are you
in
in
there.
here?
I got people on my enrichment,
Wait,
I
what are
can
you
tell to
talking
go there.
The thing back
And then I
there.
told like the ones we want to go.
What about it?
And then we can grab people.
My
if we need to do
words. The little
Were you in here when we talked about that's going to be due on Monday?
No, but I would like to make sure to get those.
Yeah, we can check that too, but,
Long enough.
okay. Okay, we didn't even get to the progress check. All right, no, it's not okay, because we have 2 free response questions and progress checks to look at. All right, I need you, listen, we gotta take the test, Friday. No, not tomorrow.
Friday.
We're taking it Friday, we'll figure it out for you, but what I need y'all to do tonight, one, if you have not done your progress checks yet, I need you to do your progress checks. We are spending a ton of time in, showing the packing so you can hear me clearly on this. We're spending a ton of time on the review of this unit because it is that important, but I need you to make sure you master it. Because I'm delaying, I don't have time to do these free response questions in class. I need you to do the 2021 and 2022 free response questions. Remember, it's a maximum of time yourself to about 13 minutes per question. This is gonna help you. One is a confidence interval one, the other is a hypothesis test one. We're gonna start tomorrow by going over those and go over the progress checks. That's it for this unit. We're moving on to the next one after that. Let me see, I made a note. So these are the progress check questions we're gonna look at. Let's quickly look at one of these. That's an old one. If you have not done your progress checks yet, please do them. They are designed to help you prepare for the test. You don't have what?
Dates, like you saying.
Look at the very top. It's at the very top.
Are you feeling it on?
Okay.
Yeah, no, don't make me, but I'm not reading my notes today.
Yeah. I apologize, but
I can
we just have to.
You wanna see what I'm getting?
So 26 minutes total. Let's look at progress check A. Was it number 9 I said?
Yes.
So right here, suppose and this is important for confidence interval. Suppose a researcher wants to use a confidence interval to estimate an unknown population proportion. Which of the following is not correct? If you do new samples, will the endpoints change?
Yeah.
Yes. Oh, I'm gonna fix that. Remember, we literally did that online applet where we collected multiple intervals and the intervals moved all over the place. That's because of sampling variability. That's why in the long run, what percent of our intervals do we expect to capture the parameter? 95%. Those intervals will move around. The probability that P is in the interval is equal to the level of confidence for the interval. That is the most common error in the way we interpret it. B is what is not correct. Either it's in the interval or it's not. The probability that the interval captures the parameter is the confidence level. Okay? C is correct. Whether the interval captures P is not known with certainty. Population proportion is fixed. That population proportion does not change. And the interval either does or does not capture P. That is true as well. Get those free response questions done tonight. Right, Joseph? I gave you a copy of them, right?
Yeah, 2 4.
So you're going to get